try again. This is a request response messaging paradigm where you have requester on one side and responder on the other side of EMS. And normally there is always 100% probability of responder, in existence while this requester, sends the message or sends the message request. But if there is no respondent, then either the request waits for an infinite time or it times out. So the requester should be at least be aware that the responder is there in existence and would be able to respond in time to its request. So this is the request reply paradigm implemented in a form of small POC from Windows Form. So the Windows Form, sends the request out to EMS. The service provider or the responder or the message consumer, picks up this request and sends back the response back to EMS, from where it's sent to or it's received by the service consumer in the form of a form itself, and then it displays on the message box. So it is slightly different from this one, where there were messages already lying from the EMS, and then simply the tap of a button on a form pull the request or pull the messages back into the form, and they were displayed either in a text box or through a message box or whatever. So these all messages which were lying here in the EMS were sent by a fire and forget publisher or a producer. So had it been a request supply, then all the messages coming into this particular process would be having reply to queue, seeing which this form should be trying to send back the reply to someone which doesn't exist. So it doesn't make sense. So it is always necessary for request reply scenario to have requester and responder at the same time, so that there are no timeouts and there are no failed communications. So coming back to the request response, so this is a small picture. So as I've explained, a request is sent from the form, from the press of a button, it goes to the service provider which is running in Designer. And by the way, this service provider is an asynchronous message consumer, and this gets the message on the same queue on which the request is sent, and then processes some part of it and checks whether it has a reply queue or not. If it has a reply queue, it sends back the reply. Otherwise, it simply goes this way and confirms it. So confirmation happens either way, whether the reply is required to be sent or not. Okay. So this is not the latest screenshot. You will see in the video the latest process. So let's come back first to service provider, because it has to start first before the form starts sending the messages. So this is it. So it's an asynchronous one. Kind of, why I'm saying asynchronous one is it's asynchronously listening for the queue and gets the message and generates the runtime info of this particular process and the business work engine too, and sends that back to the requester and then confirms it. So that's pretty much it. So in the cases where the requester is not existing, it still tries to send the request reply back by seeing the reply queue. But since that is not delivered, it goes out and errors out, and again it's confirmed. I will show you, probably I will illustrate you here as well. And let me show you the, this is the same queue which the requester in the form would send the request on, obviously. So this is the queue, this is the one. Consumers will be www.q1, and of course acknowledgement mode is client, and number of sessions will be probably 5 somewhere. Yeah, 5. So there will be 5 threads running here, and it is JMS. Of course, it's JMS based, but it's SSL2. So this is the personal configuration. We have the trusted certificates folder, and although it will be overridden, this is overridden because we have this value which contains all our trusted certificates. You see here. So these are all the trusted certificates which are imported into the trust store of designer. Okay. So first of all, I will have to start the provider. Okay, and see how it starts. At the moment, there is only one consumer, which is with Bitcoin message tool itself. Let me start this. Okay, and if you see now, so the 5 instances of this particular consumer has started, of course of the same connection, but different sessions, and no messages have been sent to these consumers yet. Yeah. Okay, and this is the queue. There are no messages on this queue. Sorry, this one. There's no messages. Pending message is 0. Okay. So this is your service provider, which is running at the moment, looking for the messages tapped into the EMS queue. Okay, and it has 5 sessions or threads which can pick 5 messages at the same time. Now this is your simple form, and which has a button and then text message. So if I press the button here, it should pop up a message box which will contain the reply of the coming from the service provider. This text box is just not for nothing at the moment, because it was better to display that reply in the form of message box rather than in the form of in this text box. And what happens when you click the button is this, I think. Okay. So of course, as you click, it's disabled, and then you have the current segment name and the labels of both the text box and the button. And then you create the message producer through this piece of code. You take the queue section, and then the queue, and then the text message, and then you create the runtime information, which is part of commutables, which contains all the threads and process IDs and all that stuff. This is the one. Okay. sending process ID, sending process name, method, thread name, thread ID, client ID, and stuff. Okay. And then this is the request call that's sent to the service provider or the message consumer, which returns this message or the reply from the service provider. And then that the same message is, the string representation of that message is shown on the message box. And it's again, it again will be in the using the SSL over JMS over SSL or SSL over JMS, whatever. If you see in the configuration, the protocol is SSL and the connection traffic is SSL connection traffic. So if I build it and see where it's built, so this is the consumer application that's built, and it's built at 55 minutes past 8, which I think is the same, almost just that back. And let me run it. I think I have explained it. So I don't think I need to explain more of the code here. I think it's quite self-explanatory to see the code lines. Of course, the queue name is picked up from the app settings, from the configuration, and there it is. Let me start the requester. Okay, knowing that we already have the service provider or the message consumer or the responder running. So this is it. So if I press the button, on the click of the button, as in the code, you should get something in the form of message box as coded. Okay. Here you go. You got this. First message. This has come from the business works or the designer. And if you see the job ID is C44000, which is I think the same as this one, C44000. And before it could send the request and get the reply and display it on the message box, it imported all the valid certificates into the store, and which it could not. It is written error log or debug log here. And there is the authentication and the handshake. Mind you, this handshake happens in the current thread, and then of course there is separate thread for reading off the data which is sent over TCP socket. So, and then after the handshake is done, and then the lookup of the queue connection factory is successful, then from that queue connection factory we are able to create the connection, which is this. Okay, so you can see here that it's SSL based. So there are 4, and if you can see, of 6 consumers, 5 of this service provider, and so if you can see there has been one message sent to this receiver and it's acknowledged too. Okay, acknowledged using this activity. So if you see what was sent by the form, it was this. What was the machine name, sending process name, process ID, method, and then thread name, which is the same as what you see on the form too. Okay, and then it sends back the reply, which comes from here. Okay, and it's same as what you see on the message box. Okay, this Docker 7 is the thread, and this C440 is the job ID, and then this activity is to send back the reply, and from there here the message is confirmed to be deleted from the EMS. So that was the simplest request reply pattern for a form. So if I do that, it should get enabled. If I just press OK here, it should be enabled so that I can request again. Yeah. So you'll see now how fast design responds. Just in a split second, you get the response back. Yeah. So that's the gist of it. Now, so you could see that the response is coming, and you can see that these are all uniformly distributed. If it's even, then it's better distributed. So there are about how many? 6 plus 2, 8 messages sent. Okay, and yeah, so 1, 2, 3, 4, 8. So 8 are received and replied back. Okay. Now, what if I, switch off the service? Let's do this way. Okay. Now, there is no service provider, and of course, it doesn't know that it's service provider. So there, I can press the button and wait. That's all I can do. Okay. So you get nothing. But if you see here, of course, this is the new consumer that's come, and this is the reply queue on which this form will be listening. Okay, this form will be listening, or its executable will be listening. Okay. Now, but there is nothing on the other side to respond back. So it's a problem. So, and now this has been coded to wait infinitely for the response. So even if I start the message off again and I start this service provider again, it should be able to receive that message and reply back. There you go, and you will get the message box with the message displayed. 34500 and 34500. Yeah. Now, another interesting thing. Let me switch off this again, and I send the message. Again, it will wait. Another reply to queue will get on. But as a end user, I see that nothing is coming. Let me close it. Not closing. Okay, let me kill it from here then. Okay, it's gone. And if you see here, it will go. I mean, it will take time. It will go. Definitely it should go. Okay. But now, if I start this again, It will try to reply back on this queue, which we just saw. Okay, but actually there's some bug with the EMS API. I would call it a bug because even if you have killed the consumer, it shows in the show consumer command line listing of the tool, and I've seen only in the .NET APIs, but it doesn't matter much. It's just a display, I would say, or maybe it's not closed. Okay, so let me try to run this. It will receive the message and the echo. So it is in red, but it has errored out because nothing is there and it's confirmed yet. So it has been coded like this, If I had not confirmed it, it would have replayed all over here. So there is a tacit understanding between BusinessWorks and ADMS that any uncount message is replayed over here again. So you will see a whole new listing building up of jobs that's applied for the same act that gets replayed back onto the same process. So if you see the consumers, this one has consumed it and acknowledged it, okay, but nothing was sent to the database. So this one now, this template is gone. You can't see it. So this 4.1 is that of the administration tool. You will see it all the time. Okay, but this one is gone. 9.11 is gone. So it takes time, just to go. It's claimed EMS says assumes, and if it's not available for more than some time, for more than 20 seconds or 30 or 40 seconds, it assumes that consumer has died away and it deletes from its own listing. So even though server provider receives it and receives it late, and why it receives it late? Because it was not there at the time of request sending, and when it receives it and it tries to reply back, the request is not there, and since the request is not there, it simply can't do much except confirm the message. So there can be another scenario where you do not want to confirm the message so that that's not late from there. But in request reply scenario, you definitely have to acknowledge it because even if you start a new requester, this requester is different from the previous one. Okay, and if you fire off a request, it will send a request, send a new request or a new request, and it will get the message. There you go. And if you see here, it has got the happy path because it was able to reply back to existing requester. Whereas in this case, it was unable to reply back because the requester was not there to receive the request. Okay. So this is the thing, one thing in case of RR or request reply scenario that if both are present at the same time, then it's the best possible or the best case scenario. Either of them is not there, then of course there will be definitely a communication gap, and which you have to overcome by some other mean or by republishing or resending the messages, or by retrying later again. Yeah. So that's pretty much that discovers the request reply, and just you have to keep in mind that in this here you will just simply have to bother about writing this. So of course, since this is a replier, if this is a requester, you do not create any consumer, synchronous asynchronous consumers, nowhere the required to be created. You simply have to put this small piece of code, and you're pretty much done. Yeah. And the responsibility of applying lies with this and that's a different environment altogether. Okay? So, this is what it is. Get back to me if you have any questions, and we'll see what can be done about those. Thanks very much. Bye.